Hi everybody and welcome to another awesome presentation in Chemistry 125. So before we get started, we need to know that pure water can be cooled below a freezing point. And if it is cooled below its freezing point, it is actually called a supercooled liquid. A lot of this times it will remain in this state until it is disrupted. So for today's experiment, that is kind of what we're going to be playing with. We are going to be water bending, and we're going to turn liquid water into ice. And the way to really do this and the awesome way to explain it is really by using science. So a couple of things you would need is you're going to need water bottles, about 5 of them. Be sure you place your water bottles in a freezer for about 3 hours in order for the experiment to work. Something else you're going to be needing is some ice cubes in a bowl, as well as a glass of water, of super cooled water. So everyone knows that the freezing temperature of water is 32 degrees Fahrenheit or 0 degrees Celsius. When this temperature is reached, the water molecules will actually freeze and will form something called an ice crystal. Now, if you have seen the movie Frozen or have seen any cute animated movie, you know that ice crystals can be beautiful, and they are normally made up of water molecules. These water molecules are often created by 2 hydrogen atoms and, of course, 1 oxygen atom, so H2O. These 2 hydrogen atoms will actually form together at an angle of about 104 degrees and will form the atomic nucleus of an ice crystal. The oxygen atom actually will then attract a larger share of electrons, and it would actually make the water molecule slightly negative on one side and slightly positive on the other. So when water actually freezes, the bipolar molecules attach to each other, and then they will actually form the hexagonal crystal lattice, or the really pretty shapes that we see in ice crystals. So for today's experiment, we are going to be witnessing the process called nucleation. So nucleation is basically the initial process that occurs in the formation of crystals from a solution. So this is not like the ice crystals that you would see falling down from the sky, but it is something that is formed from a solution, such as a liquid or a vapor. Normally it will have a small number of ions or atoms, and the molecules will actually be arranged in a pattern or a characteristic of a crystalline solid. This normally is a site upon which additional particles are disposed as the crystal grows. So just as I was talking about, basically what we're going to be doing today is we're going to be forming those ice crystals within a liquid solution. So it's easier for a water molecule to actually turn into ice on top if it has already formed crystals. So ice crystals actually build on existing ice crystals to eventually freeze the entire water bottle. So you're going to start off slow, and then what you should witness is the bottle being liquid, and then you're going to tap the side, and then it should start from one end of where you tapped, and it should reach all the way to the bottom of the bottle. So that is basically what we're going to be looking at. So what if the bottle now does have impurities in it? So nucleation cannot begin if the water is not pure. That is why it's very important for this experiment that you use a water bottle that is purified water. I actually have purified water right here. So even if temperatures are below the freezing point, if there's anything inside it that is going to disrupt it or make it impure, the water will actually stay a liquid until something kicks it off or it just wouldn't work. So the water in the water bottle won't be frozen solid, but it will actually be a little bit like a slushy, which is pretty cool. So for the experiment, we're going to take the water and we're going to place it in the freezer. Like I said, we're going to keep all the water bottles in the same position, and we're going to try and take away any dents or any flaws that we have in the plastic. We're then going to wait about 2 hours and 45 minutes, or I waited 3 hours, for that water to really get cold, but to not really be frozen. You want some part of the bottle to still be in a liquid form. If this is the case and it is not fully frozen, just try the technique of shaking it or hitting it, or even disturbing the water bottle until you can see that instant freeze. So for the first step of the experiment, we are going to basically flash freeze a water bottle, and it has, or this water bottle has already been flash frozen. So what you would do is you will take your water bottle and you will tap the side, and the entire water bottle should then turn into liquid. And that is basically what it is. For step 2 and 3, I could not do these on camera, but I can explain them though. So for the second step, you want to place ice cubes within a bowl. And what you're going to do is you're going to take your super cool water and you're just going to lightly throw it on top of the ice cubes, and you should be able to create a nice little ice structure with it. It should be a very fun experiment. I did try it earlier in the week and it did work. However, I just could not catch it on camera. The third step that we are required to do is also to throw the super cool water in a clean glass, and then you will just put a tip of an ice cube in it, and the entire glass should also then flash freeze. This experiment is extremely fun, and I am definitely going to try it out again. Some things that I believe I did wrong was I did not place all my water bottles in the same position. Therefore, only one water bottle came out ready to be frozen. All the other water bottles were actually completely fully frozen, so I was not able to use the water. So definitely would put in more than just 4 water bottles in. I would try and at least do 8, so that you kind of have the extra if it goes wrong. Another step I would do is probably do this in the kitchen. As I was walking upstairs, this one actually froze, so I was unable to do that on camera as well. But I hope you guys enjoyed this experiment, and I wish you guys the best. Bye-bye.